Okay. So yes, just reminder the fact that custom mode is the best practice for production. And the default and the auto mod network is pretty cool to do some proof of concept. Auto mod, one subnet per region, automatically created. Each time GCP is providing more region, you automatically have a new subnet inside this region. You don't choose the IP addresses. And custom is more flexible. You are controlling which subnet in each region that you need to just open for your workload. Okay. Infrastructure as code. So next station, the last session, sorry. I was using Terraform a lot. This is definitely the good practice to just handle your infrastructure and your deployment resources. So GCP first was providing Cloud Foundation toolkit. This is still the case. This Cloud Foundation toolkit is a GitHub repository made by Google with a bunch of predefined modules just ready to use to just deploy a bunch of resources inside GCP. Config connector is a specific solution that you can deploy inside the Kubernetes and to be able to just deploy your infrastructure resources with YAML. This is very powerful, especially if all your applications are workload container based and if you are using already a GKE, okay? Because you can have your deployment, your service, all your Kubernetes resource right in with YAML and also have your Cloud SQL instances deployment resource right with the same syntax with YAML. So Terraform, this is the classic solution to just begin with infrastructure as code. And Helm is a package manager for Kubernetes deployment. So this is based on rendering and templating some YAML to package an application to be able to deploy it, upgrade it, and delete it from a command line. You can see Helm like apt or yum for installing some package inside your virtual machine. So what action does the Terraform apply command perform? Download the latest version of the Terraform provider, verify the syntax of Terraform config file, show a preview of resources that will be created, or set up resources requested in the Terraform config file. This one is pretty easy. I think you all have it. Apply. If we are applying something, someone? No. No. If we are applying the Terraform apply. Yeah. Apply is deploying the resource.
But it's tricky, right? Because if you're doing apply and if you don't do auto approve, if we go to the bottom of it, it's not going to really apply. You will just prevail.
Yeah. Terraform is pretty cool. But yes, you need to know what it's going to do. Here I have a repository with a bunch of Terraform files. Basically, I was applying those Terraform code just before the session. So with this Terraform code, I just deploy a GKE cluster, okay, with a bunch of files inside this Terraform. So the workflow basically for Terraform is to init the Terraform code. The init command is basically downloading all the required provider that you want to handle inside your infrastructure as code. So here, this is already done, but basically the command is telling us that, okay, I'm going to use some provider. You can see provider as plugin. HashiCorp, with the company who is creating Terraform and a bunch of all pretty cool resources, are just providing us the Kubernetes provider, for example, the Google and the Google Beta provider. So basically, see that like a plugin, a wrapper, who can just manage the fact that we are talking with API resource deployed inside GCP. Okay? So Terraform init is the first command that you need to play when you are playing with Terraform. The second one is the plan. The plan is just telling us what's happening right now with the state of our infrastructure. As I told you before, I already deployed my GKE cluster, okay? And the fact that I've already deployed it is just the fact that I'm applying the code is creating a Terraform state file, and you can see this state file as the true statement, the persistence of the information of the resource that I've already created inside my Terraform code. So basically, this state file is very critical. Okay? If I move it outside my folder, and I'm doing Terraform init again, and Terraform plan again, boom, it wants to recreate my infrastructure from scratch. It don't see the state of my infrastructure. For Terraform, this infrastructure is not already deployed. Okay? In production, the Terraform state file, you put it inside a bucket, for example, inside GCP or S3 bucket. And because this is a kind of database very critical, you activate the versioning of this file. Because if you are doing something wrong with your Terraform state file, you can recover it from a previous version, for example. Okay? So I'm going to re-put my Terraform state here inside this folder. I'm doing the plan again. No changes. My infrastructure matches the configuration. If I go through the web console and I'm changing the parameters with declare inside my Terraform code, we are talking about drifting. And if I do Terraform plan, Terraform is going to see the change of my infrastructure. It wants to change it again. Okay? And if I do Terraform apply again, with a bunch of options to just boost it a little bit more, nothing happened. No changes. Okay? So basic life cycle of a Terraform use case, Terraform init, Terraform plan, and Terraform apply. And for a demo, Terraform destroy, for example, because it's costing a lot of money. Yes. What's the benefit of using infrastructure as code? You generally don't do that inside your local terminal, but you are putting your infrastructure as code inside a GitHub repository, for example. You are putting some CI/CD pipeline to just handle the fact that you can version your infrastructure as code, you can audit, you can work like software engineer, working as a team. Multiple people can just do some pull request inside your code, and you can think about a more flexible way to handle the infrastructure, okay? So yes, infrastructure as code and Terraform code is inside your GitHub repository. You can just play with GitHub Action, for example, to handle the pipelines and the continuous deployment. GCP has a dedicated service with Cloud Build. Cloud Build is the managed service who can do some pipelines, some CI/CD pipelines. You connect your repository inside Cloud Build. you define the trigger that you need to implement to just handle your custom deployment. So yes, Terraform is a great solution. So lifecycle, init, plan, apply, and destroy if you want to remove your infrastructure. But don't do that in production for sure.
So then here's a question
Yeah.
for everybody here. Why should I use Terraform? Like I have console, I have terminal, so what's the benefit you see as an experience in GCP? How Terraform can help? But I can use even console to create.
You can use it in console, but honestly, in 2 minutes with my code, with reproducible, I can just deploy 100 of resources, do that in the web console in less than 2 minutes.
Yeah.
It's not human possible.
That's the certification question as well. So for the Terraform, how it can help?
Exactly, because just a quick reminder here. Wow. So many stuff. Okay. I have the declaration of my GKE cluster, not here. Here. So I'm using a module already made by GCP. I'm defining a bunch of variables. And the affectation of the value of my variables are just here. I'm defining the project ID, the network, the subnet, some stuff related to my network, but I already give you the access for the GitHub repository with this code. You have the same files, terraform.tedvars.example with empty value for this in terms of values affectation. Basically, you take my code, you put your project ID, you are changing all the information related to your project, you do Terraform init, plan, and apply, you're going to have the same cluster as me. Okay? So yes, you can reproduce and duplicate your environment very quickly. You can just do some proof of concept with the destroy command at the end to just minimize the cost of your infrastructure. But yes, there's so many benefits to use Terraform. It's a little bit tricky to begin with Terraform, but there is a bunch of documentation, a bunch of modules already done by the community inside GitHub. Yes. Inside the company that I'm working with, nobody can create some resource manually inside the web console. They are using templates, Terraform, that all the developers can use. But nobody can just click on the console. The buttons are gray, they cannot create. Even me, I cannot create some resource inside GCP.
So console is good for just for testing purposes or do some...
Yeah, testing, quick testing, debugging, viewing the log, just see the configuration, because sometimes it's tricky to just see with Terraform what kind of configuration. And this is not the same attributes or argument that we are using with Terraform and the same naming convention that they are putting inside the web console. So yes, web console is just to view, to navigate, to see, to discover. There is some exception for sure. We have a bunch of projects with sandbox name inside the project ID, and especially for those kind of projects, we can have some EAM roles with more privilege to be able to create a compute instance, for example, or stuff like that. But yes, best practice for production infrastructure deployment resources is using Terraform. Okay, quick check. Which data storage service is using globally available, horizontally scalable database with relational semantics? BigQuery, Cloud SQL, Spanner, Bigtable. So BigQuery was for data warehousing using a SQL query, but is this the right solution to handle relational semantics? Not especially. Cloud SQL Is this service globally available?
No.
Does it can scale horizontally? Nope. Spanner?
Yes. That's the answer.
Yeah.
So whenever we see global, that means spanner. Like
Yep.
most of the time. Because Cloud SQL, I was not sure if for horizontal, but
No.
for sure it's not,
No.
globally is not available, it's regional, right?
Totally. And big table is a NoSQL database.
So why not big table? Big table is also like, it's global, like why not?
It's not globally. It can scale horizontally,
Or
but you have
it's
to
not-
manage.
yes,
You have
it's
to
not
manage
global.
the underlying infrastructure.
But when we say relational, so that also comes with the, okay, big
Yeah.
table is out.
Exactly. And big table,
Is out. That's
the use case of big table is generally we have colleagues who are working with Communoto, so you are handling a ton of telemetry information with IoT. So basically, those kind of database is perfect to store those kind of data because there is a high throughput in terms of write access, and this is typically not the case for BigQuery. BigQuery for handling the writing, we cannot talk about high throughput in terms of write. Okay. Yeah.
it's time series for big table.
Yes. For example, time series, metrics, all the information that the IoT use case are handling. For
there's
example.
another thing for the BigQuery. For the longer time, I was thinking BigQuery relational database. So maybe the BigQuery is the answer, but it is the analytic stuff. It's not like day-to-day transactions. Like when you're doing any transaction, going to BigQuery. No, it's not for that. So BigQuery is for analyzing our transactions.
Exactly.
What we call it like the whole data, right?
Yeah.
It's not for day-to-day work, like with the daily transactions.
Last time I was with the Cloud Function, was transforming the data, store it inside BigQuery. The only stuff that I show you inside BigQuery was the fact that I can just plug this data source for a data solution, a data visualization solution with Looker Studio. This is the use case. BigQuery, you plug it inside a Power BI or whatever the kind of visualization data solution for BI solution. And yes, you can handle your dashboarding and stuff like that related to more business use case finally. Cool. Which services are based on logic implemented inside containers? Choose two. Easy. BC? Yeah. Cool. We are starting the session of today. Yes, there is some coffee. Okay, cool. So the famous symbol, no worries, guys. So I was a little bit in advance last time, but I show you with Terraform how to create an instance template with a startup script, with installing Apache, with creating an index.html file. I deploy an instance group managed with an external load balancer, with the different section of the auto-scaling group to be capable of handling more new connection for our website and scale automatically based on the CPU consumption, and so on and so on. So we already have a question about the fact that we need to upgrade as soon as possible a new version of our website with deployed inside an instance group based on a version, based on a template. So yes, this command is for starting a rolling action update with a new version template with the famous flag proactive. Okay, proactive directly. There is a new instance coming into the group. When she's healthy, the old one is removed, and so on and so on. This is a basic rolling upgrade. If you are knowing Kubernetes, this is the same behavior, the classic rolling upgrade section. we add the new one, and when it's up and running, we remove one older. Okay, last time also with Kubernetes, I deployed the same web application inside the deployment, expose it via a service. I was not using an ingress with another type of load balancer managed by GCP. I was using the new gateway APIs that GCP is providing inside GKey with the new standard for exposing internally or externally load balancer to expose our service. This is the old-fashioned way to just deploy the same load balancer, but with an ingress inside Kubernetes. So this annotation is very, very important. This one. This annotation is telling GCP basically that yes, please provide me an external load balancer for my ingress. Okay? If I don't put this annotation, nothing happens inside my GKey cluster. The deployment is here, my pods are up and running, the service is working like a charm, but I don't have any public exposure. Okay? So basically, this annotation, you need to keep it in mind. And if I change it to GC-internal, this is an internal load balancer. Okay? And basically, this object is just telling us that, okay, to reach my application /sales, I need to reach a backend with my sales service with listening on the port number 6000, a lot of numbers. Cool. I was telling you that the SDK is providing us the gcloud command, the deprecated gsutil command to just manipulating the bucket and the object. There is also this command line with BQ for BigQuery. And with this command, for example, we can create a table inside a BigQuery dataset. Okay? So BQ, MK, make, with a bunch of flags. I don't think you have a lot of questions with this command line for this exam. I don't use it a lot, BQ, but you can just play some SQL command with the BQ command line. You can. The only thing that I'm using with BQ is just to grab the schema of my table, for example, or my data set. Okay? But
So the certification, we just need to be sure about what is MK means. They're just asking about these kind of like you can create it, you can delete it, or move it, or load it, right?
yeah,
So there's a load.
yeah, BQ load exactly. Yeah.
The-
You can effectively, with this command line, load a CSV from your local compute machine, from your local desktop, inside the table, for example. You can use those kind of command line. Okay. Managing compute resource. How many time do we have, Florian?
Usually 10 minutes.
I think we can see that. Yes, I can show my screen. Okay, compute engine. No, I don't have compute engine deployed inside my project. Okay. Quick recap. I'm going to create quickly a new compute engine based on Debian. I'm staying with the default machine type with the FinOps one. We can, yes, I love Debian. This is cool. I'm not backupping my machine, but yes, you can backup it. We have a bunch of options in terms of replication. Here, this is a feature with really pretty cool inside GCP. We were talking about firewall rules. Generally, network system administrators are based for creating their firewall rules, are handling the source and the destination in terms of IP management. Okay, this IP can reach this IP, stuff like that. The fact is the cloud is elastic, and sometimes you have automatically new instance and new IP address created along the time of your life cycle of your application. Okay, so keep in mind the famous managed instance group who can add more instance, so basically more IP address. So each time we have more instance, we cannot reach the network sysadmin to tell him, hey buddy, I have a new IP range, can you add it inside the ranges from the source to reach the front end between the backend and so on and so on. GCP is providing us a great way to handle dynamically finally the source and the destination based on network tag, okay? So what does it mean? It means that this tag is just providing me an affect inside my compute instance, a firewall rules that allow me dynamically to reach via the Bastion identity aware proxy, EAP, managed by GCP, the fact that I can handle an SSH connection to my private instance. Okay? I don't have to handle IP management in terms of firewall rules. We can manage it via network tag, and we can also manage it in terms of service account. Remember that we can put some dedicated and custom service account inside our compute instance, for example, and not especially just the compute instance. And we can handle the direction of the traffic and the control of allowing or not allowing traffic between instances based on service accounts and based on network tag. If I don't put this tag, I cannot manage my SSH connection, okay? That's why I'm putting this tag right here. So I don't have any network inside this project because I'm using shared VPC. We're going to see that in the next session. I don't want any public IP. This is not secure. Yes, I'm installing the Ops agent to just be able to send all the logs and all the metrics inside cloud operation with the observability suite that provides GCP for us. I can use the compute engine default service account. This is definitely not a best practice because this is not a service account that I with custom. This compute default engine service account is created by default at the GCP project creation. And this service account has a big EAM role with a lot of privilege. Okay, so the best practice is to never use this service account. I'm going to use the best practice. I have created a custom service account with minimal roles to be able to send the metric and send the log. Basta così. Don't forget, you can generate the command line. You can generate the command, the Terraform code. This is pretty cool. I'm going to create my VM. Creating a virtual machine is pretty fast. Deleting is not so fast. So here we can see that we only have an internal IP. We have the network tag. We have the network with deploy this subnet that we are using inside my network interface. The machine is working. It's green. We have access to some metrics. I just start the machine, so we don't have metrics for the moment. There is a bunch of services that are pretty cool. We can install some other agent to be able to have a lot of information inside my compute instance, all the packages or all the processes that are executed, and I can also update it. You can see that like an Ansible or stuff like that to do your config and patch management. This solution is a VM manager. I think we can see it, patch and OS policy. With some YAML definition, you can define your strategy to just apply, upgrade, deploy, remove some services inside your console, your VM. And finally, no external IP, but with my little network tag, I can have a command, a dedicated jcloud command. We can see this flag, which is really important. We are doing an SSH connection with a tunnel with the Bastion host IAP. And yes, if I'm doing this command inside my terminal, I am inside my virtual machine. With totally private. Okay? No public IP. If I can do that, it means that I have a IAM role dedicated with IAP user that we can put at the compute instance level. We can put that at the project, the folder, or the organization, depending the needs. But yes, I'm inside this VM. This is a free solution. Yeah. One important thing here inside the my compute instance, I can see the detail of my network interface with the internal primary IP address. And this is a pretty cool feature. I can see the firewall rules that are attached to my compute instance, okay? And here I can see if the firewall rules, who is talking about ingress IAP SSH, and we can see here the detail of the firewall rules. We have set the direction of ingress, incoming traffic, to my VM, with targeting instances that have the target tag EAP-SSH, and this IP range with public. GCP is providing us this range. It's telling us that, okay, you want to use IAP. This is the IP public address of the famous service, the Bastion services. Though, don't be afraid. This is pretty secure, okay? And yes, the port is TCP 22. That's why I can reach my private VM via this Bastion. So definitely a good practice to implement inside your VPC. And just please don't put public IP inside your compute instance. This is not a good practice. Cool. Yes, very important thing. We can snapshot our VM. So basically, before doing some upgrade, we are managing a critical upgrade inside our VM because we are upgrading, I don't know, MySQL 4 to MySQL 5 or whatever. Yes, we can do a snapshot. From the snapshot, we can create an image, and from an image, we can create a VM. So there is a bunch of mechanisms inside GCP to just be able to back up your VM, snapshot your VM, back up your disk, restore your disk, create an image based on a snapshot, and so on and so on. You can for sure schedule a snapshot scheduler to just be able to back up your VM each time. The important thing you need to understand is that the first snapshot is telling the full picture of your VM, all the disk, and after that, this is incremental, okay? So the first snapshot is taking a little bit of time, depending the size of your compute and your disk, but after that, this is incremental backup, okay?
Just a comment in terms of images, just take that into account for the certification. There are certain tools that can help you to create images using HashiCorp, and the Packer is one used, so in case just have that image.
Yeah, Packer is a great solution. And Packer is generally used to build your image templates, and you can just handle the automation of installing some package, dependency, or whatever. Okay, you want to view a description of your available snapshot using the command line interface. What jcloud command should you use Yeah. JCloud, compute, snapshot, list. The verbs are create, delete, update, list, describe. Okay, don't forget the flag, dash dash, project and your project ID. You can set your default project with the command line. So basically this is this kind of command. So jcloud config set project, my project ID. What does it mean? Each time I run a command, this is the default project. Each time I run a gcloud command, if I forget to put this flag dash dash project, it's going to run this command inside this project. That's why I was comparing kubectl and jcloud command, namespace inside Kubernetes, and GCP project ID, because this is the same mindset, okay? Cool. You have a scheduled snapshot you are trying to delete, but the operation returns an error. What should you do to resolve this problem? This is a typical question that you can have for an exam. See? Yep. Makes sense, finally. You have a relation between two objects. Before deleting the top level object, we need to just remove all the dependency. So yes, snapshots are incremental. We have a persistent disk. The first snapshot is a full snapshot. Snapshot 2 is only containing the blocks that are different in snapshot 1, and so on, and so on, and so on. Okay, Kubernetes. Kubernetes. Everybody knows a little bit Kubernetes. I can't remember. Yes, a little bit. Okay. Question. I give you the answer a little bit earlier, I think. Symbol Superstore GKE cluster requires an internal application load balancer. You are creating the configuration files required for this resource. What is the proper setting for this scenario? No, I didn't give you the answer. This one is tricky. So A, annotate your ingress object with an ingress class of GC. I told you that if you want to have an internal application load balancer, it was GC-internal. So this is not the A. Configure your service object with a type load balancer. That was not the kind of the YAML that I share with you guys. It was an ingress. Annotate your service object with a neg reference. Implement custom static route in your VPC. Right. Routing is totally managed by GCP by default. You don't have to handle routing management except for some tricky case. So definitely overkill to make D. B? No. Yeah. This one is a little bit tricky, but I can just finish the session with a demonstration. So I am inside the Kubernetes cluster. I have already deployed my namespace symbol. I'm gonna do a command with pretty much like the jcloud config set project. I'm defining my active namespace as symbol. I'm gonna use a declarative command to deploy, pour just create, this is not here, sorry guys. I'm creating my pod. I'm using GKey autopilot cluster. Remember, I don't manage the node and the node pool, so definitely not managing the underlying infrastructure. So kubectl get node. I don't have anything, but for the moment, because I'm just deploying some new pod. So we are waiting the creation of the pod, but behind the scene, GCP is providing the node pool automatically. Okay? So the pod are pending for the moment. I think if I... Okay. GCP is creating my node. It's not ready for the moment, but it's deploying a compute instance inside my GK cluster, who is acting like a node. And when it's going to be ready, my pod need to change. Okay, directly. Container is creating. Node is ready. Thank you, GKey. I'm going to apply my service with the object with logically load balancing and discovering the endpoint of all my pods inside my GKey cluster. So this is just an object internal. And the ingress here to just deploy my load balancer. So deploying an ingress inside the console. Under the hood is deploying a load balancer, but is also deploying network endpoint group. This is the tricky part, but this is the complexity of GCP finally. These network endpoint group are just some logical objects that are managing the redirection of the traffic to my pods inside GKey, okay? So for the moment, I have this network endpoint group. And if I go to GKey cluster, here, I can go to my gateway, services, and ingress. Okay, I have an ingress with a type GCE, so it's an external HTTPS load balancer for my for just redirecting the traffic to my my GKey service with Symbol Web. So it takes a little bit of time to deploy this resource, but normally, if everything goes well, we can see a load balancer with creating. For the moment, we don't have.
It will be an internal load balancer that will create?
Sorry?
It will be an internal load balancer?
No, this one is an external because it's a GC annotation, okay? But yes, the documentation is telling us that if we want to deliver an internal load balancer, you need more than this annotation here. You need another annotation inside your service. That was the question of the quiz. For the external load balancer, if I don't have this annotation, the load balancer is working like a charm. But for the internal, you need this annotation. Don't ask me why. Read the fucking manual, as we said. So basically, I don't need it, but I just put it inside the YAML to just show you that, yes, this annotation is required if you want an internal load balancer. And that was the question on the quiz. Yes, it takes a little bit of time to deploy this load balancer, but it's going to happen in a few moments. So basically, we have the backend. Load balancer is inside GCP. You have a bunch of resources. We have a front end with taking the front part with the public IP address. Behind the load balancer, we have some URL maps to just tell that, when /home is reaching from the end user, we can just route the traffic to this backend service with my pod, my Cloud Run, my compute instance. And if I go to a /about or whatever, I'm I can reach another type of backend. Who can be a multitude of type of backend. You can have one load balancer with a lot of backend and do a lot of fine-tuning inside your routing selection based on the host, based on the path, stuff like that. But we definitely need more time to just cover the load balancer. So yes, we have a load balancer. If I go to my load balancer, I can see that all the traffic from all the hosts and for all the paths are rerouted to my symbol web. Okay, so basically, if I go there, there is a. This is not so quick, but yes, in 5 minutes, 2 minutes, my website will be running. Cool. So this one is you need to know those kind of stuff. You cannot invent it. You have to know. If you are taking the exam, you need to know that. So internal versus external load balancer. The client is reaching an ingress. The ingress is based on a routing rule who can just pinpoint the service, and behind the service, we have a pod. Okay, so kubectl applies the deployment, is creating the pod. Kubectl apply services is creating the service, and kubectl apply ingress is creating the ingress. With different ingress class, it can be internal or external. Okay? What Kubernetes object provide access to logic running in your cluster via endpoint that you defined? Yep. That's it. If I describe my service symbol, I can see an information that this service has 2 endpoints with 2 IP addresses. Okay? And if I type this command line, I can see the IP address of my pods who are behind this service. And yes, this is the 2 endpoints are the 2 IP addresses of my pod. So the service is, yes, effectively a logical object who can just manage the routing traffic for your pod. And if I add a replica, come on. Okay. More pod, more endpoint to the server on the service.
And there is a kubectl get EP endpoint.
Yeah. True.
And those ports are using the second subnet that you deployed in the.
Sorry?
It's using the second subnet, or it's just.
Yes.
Yes, right?
Yeah, absolutely. I can show you in the console quickly. If I go to the Kubernetes cluster here, I go inside my cluster, inside the details. We can see on the networking part a bunch of information. We are using a VPC inside another project, shared VPC. The node are using this subnet. This is a primary subnet. And the pod are using this subnet. We can see that we are using the good subnet. And we are using another secondary range for the service. If I go there, okay. Okay, primary range here for the node, this one for the pod, and this one for the service. Cool. Some question, guys? Kubernetes is pretty cool. It's a little bit hard to start with, but yes, this is a good solution to handle your tons of microservices or whatever the kind of application. It's a little bit more tricky if you are doing some stateful set or yes, managing databases inside a cluster. It's a little bit hard, I think. But yes, if you have stateless application, this is cool. Cool. I'm going to destroy all this infrastructure because it's costing a lot of money. Thank you, guys. Bye-bye. C'était quoi déjà? Waouh.
Merci.
Je t'en prie. Again? Sorry.
Okay, the next event is next Tuesday after the long weekend. Make sure you RSVP. Look into the workbook. Don't forget to use your credits and Google Skill Boost hands-on work labs. You all have those. This is the new one. You scan it.
Good. Okay. Perfect. There's also this. This is a demo repo, so the Ben's repo.
Yeah.
Good.
Don't hesitate to play with it. It's ready to use. Some Terraform values inside the Terraform. .tvars, but you can go.
Perfect. Don't forget to follow us, all that. It's the same as always. And yeah, see you back next Tuesday after the long weekend. Thanks.
Thank you, guys.